Well, hello again, ladies and gentlemen. Today we're going to look at the substitution method. I really like the substitution method. It's probably one of my favorite ways of solving system of equations. I don't know why. It's just something that it's always clicked with me. It just seems like one of the easier ways for me to do these. It doesn't involve having to have a graph like the graphing method, and just for all around purposes is one of the easier ways if it's set up the right way. So, anyway, what I find is that um, it's one of the easiest ways if the y or the x is already given to us. So it's already solved for. In this case, we see that y equals 3x plus 5. If we had x equals 6x plus 4 or 6y plus 4, something like that, that would be an easier way to do it. Substitution method, I think. And we can always solve for it if it's not given to us. But if I see, again, something like y or x by itself, and then right away, I'm going to be like, wow, I think I should probably do this substitution method. Yesterday's, what was the way we did it yesterday? The equal methods value or equal value method. That one was also would have been a perfect one to do a substitution. I might challenge you to try and do that one through substitution if you think about it later today and just see if it works out. You should get the same exact answer that we got yesterday. So let's take a look at this in terms of the substitution method. Um, what I have here is, again, two equations that would give us a line. This one, without a little bit of work, is not going to be super easy to do as a graph. So that's why I would suggest learning how to do these different methods. You could turn this into a y equals mx plus b format, graph it, and come up with the answer. It just takes a little bit of work, and you're going to have a pretty big graph with some of the numbers that are involved with that one. So, what we do with the substitution method is that we realize that y is 3x plus 5. So, what we do is we take that 3x plus 5, which is y, and we plug it in here for y. And so what I do is I take 4x plus 2 times 3x plus 5. So since y is 3x plus 5, I can plug it in here for this y, which is 3x plus 5. So I'm going to take 3x plus 5, plug it in there, and then that's still equal to 30. Well, what I have to do now is I have to distribute that 2 onto the 3x and the 5. So I get 4x plus 2 times 3x is 6x, and 2 times 5 is 10. That equals 30. Now I have to combine my like terms. I've got 4x and 6x, which is going to give me 10x. Still have the plus 10 equals 30. And then I need to isolate the x, get it by itself. So I'm going to take away 10, both sides. Again, do the wall if that's the way you prefer it. And then I end up with 10x equals 30 minus 10 is 20. So from there, divide off 10 both sides, and I get x equals 2. So kind of like yesterday, again, I have x equals 2